Hey my dear scientists, how are you all? I am Hina and I am once again here with all of you, and I've brought a brand new video for you all to enjoy a lots and lots of knowledge with fun. So my video is about the root and the base of chemistry. So that is the smallest unit of matter. It's the smallest thing on earth. So can you guess? Yeah, I'm waiting. Yes, you all are right. That's atoms. So we'll talk about atoms, its structure, all the properties about it, and etc. So friends, to talk about atoms and not to talk about matter is actually foolishness. And I don't want you and me to be foolish. So we'll talk about matter also. And as we're talking about atom and matter, we must talk about the octet rule too. So let's begin our video. Atom. Now this is the structure of an atom. This is actually a rough figure. So let's now define this structure of atom. So this blue ball which is in the center is known as nucleus. So now we know that atom is the smallest unit of the matter, but still atom is made up of another smaller units, that is subatomic particles. Okay, so there are three subatomic particles. The first is proton, second is neutron. I'll tell you thirds in a while. First, let's focus on these two. Now, this proton is denoted by small p with a plus positive charge on it because it is a positively charged subatomic particle, while neutron is denoted by symbol n, small n, because there is no plus or minus above it because it is a neutral. There is no charge on neutron. Now the third subatomic particle is electron. Now what's the difference between these three? That these two, proton and neutron, are actually present inside a nucleus in the center of the atom, while electrons are just revolving around this atom, this nucleus, like planets do around sun because of its gravitational bind. So this E, that is the third subatomic particle, that is electron, and it is denoted by E minus. So I hope that's clear. Let's discuss it further. So now the atom is, as we know, this has three subatomic particles, and this proton, neutron are in the nucleus, which is the center of the atom, and electrons are just around. It is like revolving around the nucleus, like planets do around the sun. So let's quickly move. So now as we know that protons are positively charged, electron negatively charged, neutron is neutral. So these three different things with three different charge. So what's the charge of the whole atom? So let me tell you, the atom is neutral. Now you'd ask how. Though proton is inside nucleus, if protons are equal to electrons in number, as positive, this positive charge, its positive charge will cancel its minus charge, and this will turn out to be a neutral atom. Now, if proton and electrons are same in number, the atom turns out to be neutral. And in most of the cases, the atom is neutral. So, this is the first point. Now, secondly, that there are many roles in atoms, different roles, many roles in atoms, but firstly, you have to really get friendly to the periodic table, and if you can't learn periodic table, like it is actually hard to run the whole periodic table, so just try to memorize the periodic table's first 20 elements first 20 elements with symbols. So if you do this, it will be a great help to you. Now now proton and neutron are inside the nucleus. So every chemical reaction which takes place, electrons are only participating in every chemical reaction that takes place, whether that's acid-base neutralization reaction or any other reaction that is an indicator test. Any of the experiments which take place in the chemistry are all the things which are taking part in the chemical reaction is just electrons. So let's now, as we have done all the things about the atom, we should now move on to matter. Now friends, matter. What is matter? So matter is actually matter is firstly everything that occupies space. Secondly, everything that has mass and weight. And thirdly, which resists externally applied force. So I hope the first 2 points are actually clear, but maybe you have a doubt in the third point. So let me explain you that matter is everything which resists the externally applied force till the force is more than its potential to resist the force. So like this is the duster, whiteboard eraser. So now I apply a force to it. So this duster, it has its own potential to resist the force which is applied to it externally, like this duster, it is very light in weight, and that's the reason it has a very low potential to just resist the externally applied force. And if I very lightly push it, that lightly that कि मेरे हिलान से हिले नहीं, इसके पास अभी इतनी ताकत हो इसके पास कि मेरी उस लाइट फोर्स को ये बेयर कर सके और ये रेसिस्ट कर सके मेरी फोर्स को और ये हिले ना. So that is mass. And now I am just moving it, so I apply more force than its potential. So let's now move on from this topic, and I hope now you have understood what matter is. So let's move on to the next topic, which is types of matter. So matter are of three types now. First is this element, second is compound, and third is mixed. Let's discuss about elements first. This element is a thing that is actually pure. It is one atom, made up of one atom only. So if, for example, if I say this O, this which denotes oxygen, according to the periodic table, which O denotes oxygen. So this O, this is an element. This is pure oxygen. No mixed up things. This hydrogen, this is an element. Carbon, this is an element. So even Al, aluminum, this is an element. So this is what element is. And now elements are of three types, which is metals, non-metals, and metalloids. Next, move on to the compounds. So compounds are of three types, which is acid, bases, and salts, which I have already explained in my last video in very detail. As when I was in class 7, there was a detailed chapter about acids, bases, and salts. So next, compound is made up of one molecule, and though compound is made up of one molecule, it is still pure because there are no two objects, only one molecule of a particular thing. Like I say O2. O2 is a compound. H2O, it is a compound. CO2, it is a compound. That's pure carbon dioxide, that's pure oxygen, that's pure ozone, and that's pure water. So this is what compound is. Next is mixture, and mixture is impure. For example of mixture, I will give you, that is a beaker. Here I have some water in this beaker, and I have poured NaCl, which is sodium chloride or common salt, sea salt, and this mixture is now a salt water. So we will say it as a mixture because this has two compounds or two elements. So first is two compounds. We have the example of two compounds. So NaCl plus H2O, which gives this salt water. Now the next example of this mixture made up of many elements is this. This is a jar, and I have closed its lid, and many air molecules are inside it. So this is air, and this air must contain many elements like hydrogen, oxygen, carbon dioxide, even carbon, and many other elements also. So this is also an example of mixture. The next topic is the octet rule of chemistry, which denotes the letter 8, the number 8. So what does this octet rule actually mean? So this octet rule has a very good connection with the word stability. So octet rule means letter 8, means every atom wants, like every atom wishes that its last row should have 8 electrons. So that is the octet rule, and if atoms do not get their desired condition completed, they will become unstable. So let me firstly give you a formula which helps us calculate the how many electrons can an atom just bear in one row. So the formula is 2n square. Here this n means number of row. So according to the formula, if I go for the first row, so here it was 2n square, so n is first row and 1 square. Now 1 square is, firstly we should solve square, so it's 1, 2 ones are 2, means the first row of the atom, the first shell of the atom will always have 2 electron and not more than 2 electrons. Okay, next is we'll find out about the second row. So 2 twos, so that is 2 twos are 4, 4 twos are 8, and so 8 is the answer for the second row. And as we found out about the, so this is the second row. Introduce you with the example quickly so you understand the octet rule as soon as possible. So this Al, I have taken here Al, which denotes aluminium. So this is 13th, this is on the 13th atomic number in the periodic table. So when we just divide it, so in the first row there will be 2 atoms, second row will be 8 atoms, and electrons. Third row there will be only 3 electrons left. So as aluminium's wish is not completed as it has desired, so it will now be unstable. Now to be stable, it needs a friend, and the friend who's gonna help it to be stable is phosphorus. Phosphorus will bind together, and so as now see, let's how it will bind together. So as you can see is it is in the periodic table, it is on atomic number 15th. So in the first row there are 2 electrons, second row there are 8, and third row there are 5. So this is how I've divided these two. Now to bind, one partner should be a metal and one should be a non-metal. In this case, metal is aluminium and non-metal is phosphorus. Metal is always going to lose and all non-metal is always going to gain. Now what is this lose gain? Let me make you understand. Actually, to bind there are 2 options, either to lose or to gain, and metals always have 1, 2, 3 electrons in their last row, and this phosphorus which is non-metal, they always have 4, 5, 6, 7, 8. So 4, 5, 6, 7, so they always need electrons, and they can never give up 5 electrons. So aluminium is ready to give its 3 electrons to phosphorus, who needs 3 electrons. Now you must be wondering, why do aluminium ले क्यों नहीं लेता इससे 5 इलेक्ट्रॉन? ले भी तो सकता है. Why he is not taking? The thing is कि देखिए, इधर इस केमिकल रिएक्शन में जो कुछ भी करना है सब में एनर्जी लगेगी. अगर फॉस्फोरस 5 देना चाहेगा तो एल्यूमिनियम को अपनी फोर्स से 5 इलेक्ट्रॉन को पुल करना होगा, वाइल फॉस्फोरस को 3 इलेक्ट्रॉन्स को पुल करना होगा. सो टू पुल 3 इलेक्ट्रॉन्स नीड्स लेस एनर्जी देन pulling 5 electrons, and that's a common sense. अब तो एल्यूमिनियम और फॉस्फोरस में भी कॉमन सेंस है कि फॉस्फोरस एनर्जी वेस्ट नहीं करेगा and it will gain while aluminium would lose, and its last row would be second, which has 8, so it will be stable with its friend phosphorus, and phosphorus will help it to be stable. So these two then bind together. So as aluminium is losing, this is, so now these two phosphorus aluminium ions, they are going to combine and form aluminium phosphate. So I hope the example is clear. This was all about the octet rule. I have explained you this with the help of example also. So that's all for today, guys. Stay tuned for more interesting videos. Please do like, subscribe, and share, and do not forget to hit the bell icon for notification of my upcoming videos.